This video introduced the live load, that is denoted by Q, and the information is given in the section number 3 of 1170.1. So if I take the some page over, in the section number 3 it has given the impose action, which is the live load. Now this live load is denoted by Q, and in Australian standard in table number 3.1 on page number 9 there is a pressure given for the various structures. So if I show it here on table number 3.1 on page number 9 of 1170.1, it has a various pressure, like a live load values are given. For example, if we are designing the office building for the workroom and for light industrial without the storage, we are considering 3 kilopascals as a pressure for designing the office building for estimating the live load. Now this is just a typical example, so the pressure will be given, but generally we are interested in getting the UDL load. So if I have same exam is going to follow the same procedure as a dead load. So if we have a, let's say, a slab in the office buildings, the pressure, as we can take it from table number 1, 3 kilopascals, but we are interested in getting the UDL load that is presented in the blue color. So we just need to simply multiply by the perpendicular length. So in this case the perpendicular length is B. We always exclude this length which is parallel to the loading direction. So our final answers for the live load is equal to pressure times the perpendicular length. For example, if you like to convert pressure into line load, which is the UDL load, into point load, for example slab, it's supported by 2 columns at each end. We know the procedure to convert pressure into UDL. We just need to multiply perpendicular. But so they will like to find a point load.
This area.
And I'm just
first we
can
convert
pressure
like this one. You just use
this one to record, this one to camera, pressure camera to record. Once we get the line load, blah 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 blah.
It's just 5 minutes, right? It's not more than this one. I think 7 minutes. No more than 10 minutes. Because
so in this case, if you want to calculate the point load acting onto the column due to this slab live load, so the point load would be in kilonewtons. So UDL times the D, which is this length. Like in the structure analysis and solid mechanics, we multiplying. If you convert the UDL load into the point load, we multiply by the length, which is parallel length, not this perpendicular length. This time we multiplying parallel length, which is D, and just half of this load to get the loading on each end. Just a unit wise, most Australian standard has given the unit kilonewton and meter. Mostly the pressure will be given into kilopascals. So pascals converted into kilopascals. So there is a 1000 multiplication, and there is a 1000 multiplication to get megapascals. So the pascals is Newton per meter square, kilopascal is kilonewton per meter square, and that is Newton per millimeter square. Interesting fact, kilonewton per meter is equal to Newton per millimeter. So if you are taking 1000 kilonewton per meter is equal to 1000 Newton per millimeter. Is actually you multiply by 1000 here and multiply by 1000 here to convert into Newton and convert into millimeters. 1000 cancel, so we have Newton per millimeters. Now for the loading, it can be Newton or kilonewtons, can be times by 1000 Newton is give you 1000, give you 1 kilonewton. So 1000 Newton equal to 1 kilonewtons. But keep in mind on these units, and that will help you to solve some of the examples. Thank you very much.